So for those of you guys just joining us, we had a few people making up Forever Finals, so everybody else was working on 2018 FRQs. Some of you might be like, but we took the 2018. No, you took a practice exam from 2018. These are the actual 2018 FRQs from last year's exam. In your Google Classroom, there is an announcement. Oh, that's honors notes, sorry. In your Google Classroom, there is an announcement. Here he is. That I added with the 2018 FRQs I passed out for people who were today, people who were not. You can print it out just like with any bonus work. There's a scoring guidelines. I made it easy, but I just added that quick little note like, yes, there are full-length bonus practice exams you guys can work on this weekend, and I would hope not Monday night, but this weekend. And then also talking about the FRQ collections that are totally up for grabs. I have a link to those past FRQs. 2017, I think, are the ones that don't show up automatically. 2018 doesn't either. So 2018, all I had to do was Google 2018 free response. They're there in the website, just not like really quickly there. So if you want 2017, you can just Google that as well. But then there's all the 2016 and before. So those are up for grabs too. Remember, the free response collections are 2 points because they're half a bonus exam. And the full bonus exam is 4 points if you attempt it, grade it, and attempt to correct it. I know on your own this weekend there's only so much you can do. But remember, the bonus exams I posted for AB, there's at least 1 or 2 where all the multiple choice have been worked out. So that would help you as well. But all bonus work is due by. Just in case I'm going to lose some of you guys, well, I'm not going to lose period 1 kids, but period 6 kids, I might lose a couple of you. Yeah, Joe Tan, you're in AP Bio. My kids who are taking AP Bio on Monday, I'm not going to see you again because I don't see you today because of the awards assembly. I'm not going to see you again until Tuesday morning up in the library. Or are we in the gym? I don't remember. I think we should be in the gym. Yeah, we have too many people for the library. We'll be in the gym on Tuesday. I think all of the signing and your names and making the forms and everything has been done this week, except for a few of you. This might be your first AP. Most of you, this is. So don't have to get there quite as early as far as from, but I will have breakfast like I always do. Similar to the Saturday APs with breakfast bakes and coffee cakes, probably coffee cakes, donut holes, all that sort of jazz. I will have also boxes of granola bars and cuties and stuff for you guys to grab in your snack in between the FRQ and multiple choice, or in between the multiple choice FRQ. So please, my advice on Tuesday morning is get there by 7:30 so you can get some coffee, you can get some food. You can be done with it, throw it away, or else Mrs. Pratt gets mad. And then be ready to take your seat after we pray together as a class a little bit before 8. So I would say 7:30. When you come into the gym, I'll remind the rest of you guys who are here Monday, if you do bring in any notes, any forever cards, any phones, they will need to be put up before you sit down. So nothing is allowed to go over to where you're taking the actual AP. Your phone's not allowed to go over there. Purses aren't allowed to go over there. Anything that's math related. And I don't think we even have any like formulas on our sweatshirt this year, so that's okay. I've had to like literally take people's shirts off their backs because it's not allowed to be in the gym. But if you have any notes or forever cards, I will have my big old cart that I brought all the food in on, and you'll have to put it on the cart before you go sit down. So also, don't just go grabbing seats like you did for the mock AP. Since some of you guys have your forms already filled out, it may be that your seat is chosen for you. You have to go find like where your name is for your answering form and stuff. So don't just go to the seats, stay away from the whole, like the chairs and come over to where the food is, hang out there. And when Mrs. Pratt tells us, then after we pray, you guys can go sit down. Sound good? Okay. Other than that, I'll remind you guys of all that on Monday, but for period 6 kids and AP Bio kids, I wanted to make sure they could hear that. Okay, guys, I'm ready. Is there any place that you got stuck or anything you want to talk about? Thomas?
1B, I don't understand.
Okay, 1B, don't understand the answer. I'm going to look at the givens really quickly. 1B, you're given a piecewise function. That's a piecewise function for rate. Yeah, people didn't like the escalator problem last year. For letter A, how many people? We know we're doing an integral. But for letter B, during the time interval 0 to 300, there are always people in line. How many people are in line? So now let's go back and talk about in line. People are coming into a line at a rate of r of t. But guys, keep reading the given. It also says they exit the line to get onto the escalator at a rate of 7 persons per second. or 0.7 persons per second. They don't say persons plural because 0.7 is less than 1. That doesn't really matter. Okay, and there are 20 people in line at time t equals 0. So this is an in and out problem. Remember, Californians are supposed to be good at them. This is people going into a line. This is people leaving the line to get on the escalator. So in, adding to, out, subtracting from. So when it says how many people are in line at time t equals 300, why am I going to come over here to the board and point at this? This takes into account how fast the number of people in line are changing from an initial amount that were in the line to figure out the final amount of who is in the line at time B. So what I see is they want to know 300. So I'm going to put 300 as the upper bound of my integral. I'm going to put whatever, well, what are they telling me? 20 people were in line at 0. I'm going to make 0 my beginning. So from 0 to 300, how did the number of people in line change? Plus the 20 people that started in line, and then that should get me my final amount. But when I go to put in the rate, since this is an in and out problem, we need to subtract the two. So therefore, we're going to say people coming in, how fast I'm having addition happening to the line, minus how much is being taken out or being subtracted. So therefore, if I'm not wrong, it should be 20 plus the definite integral from 0 to 300 of the in rate minus the out rate. Oh, they just solved this one by hand. So this one they did in their calculator, and then this one they said, oh, hey, that'd be 0.7t and plug in 300 minus 0. That's just them solving by hand. If I were you, I would have just thrown this whole thing in your calculator. Sorry, this whole thing in your calculator and get an 80. So don't stress. They were just doing like a little like, oh, that's really a rectangle because it's a constant rate. And your calculator would have been fine.
I have a question about units. So for part
Yeah.
A on this problem, I got the answer right and I just put 270 people, but do I have to put like that whole justification at the end to get the answer right?
Let's see what they asked. So what they technically asked was how many people. Nope, you're good. What they do in the answer key, and what could be a good idea, but it's totally up to you. They just, and you could just steal their wording. They love full sentences because you're talking about the situation. So in other ones, when they say explain or justify, they want like a full situation, a full picture of what's going on. And so the safest thing is to always just steal what they said. You don't have to say according to the model. But it's not ever a bad idea to say 270 people, oh, what were they saying? Steal the words. Enter the line for the escalator between 0 and 300. You can shorten it, but you wouldn't have lost points if you hadn't put all the words. Just be aware when they say explain or justify, they want the full situation. Stealing their words is great. Okay, anything else on number 1 or any of the other FRQs? I don't mind jumping around. 3? What part of 3? Okay, so number 3, if I was to give this one, hey, you guys saw a motion one, right? And then this one was an in-out one. So we had in-out, we had motion. This one would be, I see geometric. Ooh, and then calculus with the curvy do. And then I see a piecewise function. Oh, I thought it was an accumulator function. Okay, so with all this given information, the graph of the continuous g, the derivative of the function f is shown above. So g is f prime. Be careful, the wording was a little bit messy. Sorry, this is back to the escalator problem. The graph of g is above, and they say, by the way, g is the derivative of f. So if I were you guys, just to make my life easier as far as thinking about things. Okay, good. The function is the piecewise blah, blah, blah. They tell me this is specifically the calculus part. And then everything else is just as you see it as far as geometric. If f of 1, you said a, right, Thomas? Why am I going to come over here and point to this again? I can know what the function value's amount is at 5 if I start with, I think, -1, and then take the integral of his rate g, the guy that I have from -1 to 5, if those are my bounds. Did I just remember that wrong? Sorry, from 1 to -5. So I'm going to say, I can know f at -5 if I know somewhere to start. I know it's awkward, but whatever. I'm starting with what they give me. So I'm going to make my bounds from 1 to -5 of rate. And who's the rate? G. And how am I going to do the rate? Well, hold on. From 1 to negative 5 is awkward. I'm going to go ahead and flip those bounds to be negative and then switch it from negative 5 to 1. Whatever I cross off in the AP, they cannot grade against. So I switched the bounds to be pretty. I'm going to go from negative 5 all the way to 1, taking into account all of my geometric areas. And I'm going to take that and add to f of 1, which is 3. Remember, area below is going to be a negative number, area above is going to be a positive number. I apologize, it should be 3 minus, because I changed the bounds. Does that make sense?
So we're finding the right angles for the
Well, the area, yeah, some triangles, some rectangles. Just remember to make below, negative, above, positive, if you have the bounds going the proper way with that minus on the outside. And stick it to the man at the end, don't you dare simplify. But then in letter B, now guys, I love this. This is so good. Because in letter A, we're dealing with the idea of area, right, from negative 5 to 1. But then they make it a little bit weird. They say, hey, go from 1 to 6. Well, hold on. How can I go from 1 to 6 of G? I mean, okay, 1 to 6, 1 to 4, isn't that more geometry? I'm going to have to split up this integral and go from 1 to 4 of G of X using geometric, and then I'm going to have to go from 4 to 6. But what can I plug in from 4 to 6? Or actually, no, my apologies, from 3 to 6. I didn't see the curve from 3 to 6. Can't I plug in this function? And I would have to anti-derive by hand, but this one is going to be area. This one's going to be area from the graph. This one's going to be the actual antiderivatives of B minus antiderivatives of A using U sub. Or if you want to FOIL it, you could do it that way. Remember, stick it to the man once you solve the integrals. Did I miss another question that you had? Okay. Is there anything else? 1, 2, and 3. If someone skipped to 4, 5, 6, I don't mind. We can peek at it. 4D. We're going to be close here to the end. Guys, I can almost guarantee that there are people that have done videos on last year's FRQs, so you could always YouTube as well and find someone who walked through them all. If you guys want to go, you totally can. I'm just going to peek at this quick with Grace. Or even on the video itself, Grace. If you have to go, it's fine. Height of a tree is G. When the tree is, I see a such that. I see a d dt, right? I want a dh dt. Don't say d dt. They told me diameter is x. So this is a dx dt. They told me height is g. They want me to find a dg dt. All I have to do is take d dt of both sides and plug in my clues. They change the variables so it looks weird to us. Does that make sense?